graphical analysis of motion. So in this session we are going to discuss about the three graphs. One, displacement time graph. Okay. Two, velocity time graph. Third one, acceleration time graph. Okay, so these are the three graphs we are going to discuss in this session. So consider a graph. So this is y axis and this is x axis. Okay, so consider a curve. Okay, so I am considering 2 points, this curve. So the x coordinate value I am taking as x1, so the corresponding y coordinate value, that is y1. Okay, so x2 is y2. Okay, so when we study about these graphs or graphical analysis of motion, two things we have to consider. One, that is slope of the curve. Slope of the curve. Two, area under the curve. Slope of the curve and area under the curve. What is slope of the curve? Slope of the curve at a particular point. Slope of the curve at a particular point is nothing but the slope of the tangent at that point. What? Slope of the tangent. Slope of the tangent. Okay? Slope of the tangent. Slope of the tangent at that point. So suppose if you want to find the slope of the curve, slope of the curve at the point P. So I am taking this point as P and this point as Q. Okay, slope of the tangent at the point P means, so draw a tangent. Okay, draw a tangent. Okay, so this tangent makes an angle theta with the horizontal x-axis. Okay, so the slope of the tangent we know that, so is equal to tan theta, So theta is the angle made by the tangent with the horizontal x-axis. My dear students, if you want to thoroughly understand this topic, that is what is function, how to draw a curve for the function, okay, what is slope of the curve, what is positive slope, what is negative slope, what is the maxima of a function and what is the minima of a function. So such things if you want to clearly understand, means in Physics 2020 there is a video, that is there is a playlist called Mathematical Support for Physics. So in that playlist I have uploaded one video, that is differentiation part 1. So in that video I have discussed these things in very detail. Okay, so if you want to know about these things in very detailed manner, means you can watch that video. So for the time being I will say the essential things only. Okay, so anyway, the slope of the tangent at the point P is nothing but the slope of the curve at this point P is nothing but the slope of the tangent drawn through that point. So which makes an angle theta with the horizontal x-axis. So that is equal to tan theta. So suppose in the similar way, suppose if you want to draw find the slope of the curve at the point Q. So draw a tangent through Q. So it makes an angle. This is theta 1. This is theta 2. Theta 2. Okay, so clear. That is slope of the curve. Slope of the curve at that point is nothing but the slope of the tangent drawn through the point. Okay, drawn through the point. So that is slope of the tangent is nothing but tan theta. Theta is the angle made by the tangent with the horizontal x-axis. So next very important thing, that is what is positive slope? What is positive slope and what is negative slope? What is positive slope and what is negative slope? So before that, so I will write the tan values of the standard angles. So theta, tan theta, 0, 30, 45, 60, 90, 120, 135, 150 and 180. Tan 0, 0, tan 30, 1 by root 3 tan 45, 1, root 3 tan 90, infinity, minus root 3, minus 1, minus 1 by root 3 tan 80, 0. Okay. So what is positive slope and what is negative slope? If the angle made by the tangent, if the angle made by the tangent with the horizontal x-axis is below 90 degree, so less than 90 degree means it is positive slope. You look at the value, that is the values less than the angle values, standard angle values less than 90 degree means it is positive values only. Okay, positive values. So that is called positive slope. If the tangent, that is if the angle made by the tangent with the horizontal x-axis is greater than, that is the angle value greater than 90 degree means it is negative slope. So or otherwise the angle, so the tangent drawn for the curve in the increasing portion of the curve. So increasing portion of the curve. So this is the when you consider this curve, so this is the increasing portion of the curve. So the curve is increasing. So at this point it reaches the maximum and this curve decreasing. In this portion the curve starts to decrease. So in the increasing portion I have drawn two tangents. So it is perpendicular means 90 degree. So angle is always measured in the anti-clockwise direction. So in this position, when from this point to this point, anti-clockwise direction, the angle increases. So this angle, that is 0 degree. So when it starts going anti-clockwise, that is angle increases. Okay. So the increasing portion I have drawn two tangents. This makes an angle theta that is less than 90 degree. So that is theta less than 90 degree. Okay, so that is positive slope. So if you draw a tangent at the decreasing portion of the curve, so increasing portion and a decreasing portion of the curve. Suppose I am drawing, this is decreasing portion of the curve. So at this point I am drawing one tangent. drawing on tangent. Okay, so if you find the angle means, so this is greater than 90 degree. So the angle value is greater than 90 degrees, that is negative values only. So theta is negative, that is called negative slope. Okay, negative slope. Clear? So positive slope and negative slope. Positive slope is if the angle made by the tangent with the horizontal x-axis is less than 90 degree means it is called positive slope, or otherwise we can say that if the tangent at the increasing portion of the curve is, that is positive slope. Okay, so the negative slope is the angle of the, that is the angle made by the tangent with the horizontal x-axis is greater than 90 degree, then it is called negative slope, or decreasing portion of the curve we get a negative slope. Okay, then area under the curve. Next is area under the curve. Suppose if you want to find the area under the curve in the between the points P and Q. So this is the area under the curve. Okay, so area under the curve is the continuous product of x and y. Okay, area under the curve. Area under the curve is equal to, that is continuous product of x and y. Suppose this area consists of n number of strips. Okay, this area, that is this area consists of n number of strips. Each have the thickness dx and the corresponding y values are y1, y2, etc. Okay, suppose if this area is divided into n number of small strips, each strips having the thickness dx and the corresponding y values are y1, y2, etc. Then the area under the curve we can write, that is y1 into dx plus y2 into dx plus y3 into dx plus etc. plus yn into dx. That is the area under curve. That is nothing, this is nothing but integration of, integration of, that is x1 to x2, that is y dx. So this is the area under the curve. So clear? So graph, that is slope of the curve, then positive slope and negative slope, and area under the curve. Okay. So the next is displacement time graph. Displacement time graph. So consider a displacement time graph. So this is displacement time. Okay. So this is a displacement time graph, so which makes an angle theta. Okay, theta. So slope of this displacement time graph. Slope is equal to, slope of this displacement time graph is equal to, so we know that is tan theta. Okay, tan theta. So tan theta is equal to perpendicular by base, that is y2 minus y1 divided by x2 minus x1. Okay, perpendicular by base. Tan theta formula, that is perpendicular by base. So y2 minus y1 divided by x2 minus s1. So in the y-axis displacement, so s2 minus s1, in the x-axis time, that is t2 minus t1. Okay, t2 minus t1. So that's equal to change in displacement, that is delta s by time, change in time, that is delta t. So delta s, change in displacement divided by change in time. So that's equal to velocity. Velocity. So from this what we can understand, the slope of the displacement time graph gives the velocity of the motion. So slope of the velocity time graphs gives the velocity of the motion. Clear? Okay, that is very important. Then, so we are going to study about the displacement time graph. So displacement time graph, the slope of the displacement time graph gives the velocity of the motion. Okay, velocity of the motion. So we are going to study different displacement time graph. Case 1, body is at rest. Body is at rest. So how to draw the displacement time graph? Displacement time. Okay, displacement time. So at a time t1, so the body is at a particular position. Okay, t1. At the time t2, the body is at the same position because body is at rest. The position does not change. Okay, so t2. Okay, so this is the displacement time graph for body is at rest. That is, at the time t1, the body is at a particular position. At the time t2 also, the body is at the same position because the body doesn't change. The position doesn't change. That is, body is at rest. Okay, so this is the displacement time graph for, that is, body is at rest. So what is velocity? So velocity is nothing but the slope of the displacement time graph. So what is the slope of this curve? The graph is parallel to the x-axis. Slope is equal to 0. Slope is equal to 0. So tan theta is equal to 0. So velocity is equal to 0. Velocity is equal to 0. Okay? Velocity is equal to 0. So the body is at rest means body is not changing from the position. So velocity is 0. Okay, velocity is equal to. So what about the acceleration? Acceleration is also 0. Okay, that is case 1. Then case 2. It is uniform motion. Case 2, uniform motion. Uniform motion means velocity is equal to constant. Velocity is equal to constant. Uniform motion, velocity is equal to. So in this case, we have two cases. So velocity may be positive or velocity may be negative. So velocity constant means velocity may be positive or velocity may be negative. Okay. So first case, velocity is equal to constant and positive. So displacement time graph. Okay, displacement time graph. So the slope of the displacement time graph gives the velocity. Okay, slope. So this graph makes an angle theta. So the slope of this, so this is a displacement time graph, displacement time graph. So the slope of the displacement time graph gives the velocity. So it makes an angle, the velocity displacement time graph makes an angle theta, So velocity is equal to the slope of the displacement time graph, that is slope is equal to tan theta is equal to velocity. Am I right? Velocity. So the displacement, the slope of the displacement time graph, that is equal to tan theta, that is the velocity of the motion. So that theta, it makes an angle theta. So theta less than 90 degree, theta less than 90 degree. So the less than 90 degree means tan values are positive. Okay, positive. So slope is equal to, therefore angle less than 90 degree, that is theta less than 90 degree. So tan theta positive. So therefore slope positive. Therefore velocity positive. Okay, velocity positive. Clear? So the slope of the displacement time graph gives the velocity. So the here the angle made by the curve, that is theta. So less than 90 degree. Less than 90 degree means tan values are positive. Tan values positive means slope positive. So slope gives the velocity. So therefore velocity positive. Kadam? Okay. So this is positive. Then velocity is equal to constant. Velocity is equal to constant. So at each and every point, if you find the slope, it gives the same slope. That is, slope is constant. So at every point, that is, if you find the here also theta, here also theta. Okay, at each and every point, if you find the slope of the curve, theta is not varying, slope is not varying, slope is constant. Slope is constant means velocity is equal to constant. Okay, so here 30 degree means everywhere that is 30 degree. Okay, 30 degree. Or 60 degree means everywhere 60 degree. So tan 60 always gives the same value. So that is slope constant. Slope gives the velocity. So velocity constant. So velocity constant, positive satisfy. Okay, so this is the displacement time graph for velocity constant and positive. Clear? Okay. Then next case, velocity constant. Okay, velocity constant but negative. Velocity constant but negative. So what is the displacement time graph? Displacement time graph. Yes. Displacement time graph. So this is the graph. Displacement time. Velocity, displacement time. So what is the slope of this curve? Yes, theta. So this is 90 degree. So when it goes like this, that is 90 greater than 90 degree. Okay, greater than 90 degree. So slope, that is 0, that is horizontal 0. So increasing. So it comes 90 degree. So gives 90 greater than 90. So the theta values are greater than 90 degree. That is equal to negative. Okay, negative. So here theta greater than 90 degree. Okay, theta greater than 90 degree. So tan theta negative. Slope negative. Velocity, slope negative means velocity negative. Okay, then constant. Here also, if you find the slope at each and every point of this curve, okay, so theta, so at each and every point the slope is constant. Okay, slope is constant. So therefore velocity constant. Clear? So velocity is equal to positive. So uniform motion. So this is the displacement time graph for uniform motion. Okay, uniform motion. So velocity, uniform motion means velocity constant. Okay, velocity constant. So velocity constant means it may be positive or negative. Okay, velocity positive or negative. So positive means, positive constant means displacement time graph. Negative constant means, so displacement time. Just like this. Clear? So in the case of uniform motion, so what about the acceleration? So uniform motion, so the displacement time graph, displacement, okay, displacement time graph. Okay, so velocity positive, constant positive, positive and negative. Okay, constant positive and negative. So what about the acceleration in two cases? Acceleration is equal to, yes, so acceleration is equal to dv by dt. So here uniform motion means velocity is equal to constant. Velocity is equal to constant. So in both the cases acceleration is equal to 0. Here also acceleration is equal to 0. Here also acceleration equal to 0 because it is a uniform motion. So velocity is equal to constant. So therefore acceleration is equal to dv by dt. So therefore acceleration is equal to 0. Okay. So the next case, non-uniform motion. Non-uniform motion. Non-uniform motion. So in this case, case 3, this is case 3, non-uniform motion. So in these 4 sub cases, A, velocity positive increasing, velocity positive decreasing, okay. C, velocity negative increasing, velocity negative decreasing. So these are the 4 cases we have to discuss in non-uniform motion. So we have to study or we have to analyze the displacement time graph for these 4 cases. Okay. So first case, velocity positive and increasing. So this is a displacement time graph. Displacement time graph. Okay. Time graph. So point at the time t1, time t2. Okay, t2 greater than t1. Okay. 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 So from this graph, what are the conclusions we can make? One, concave upwards. The graph is concave upwards. Okay. Two, theta less than 90 degree. So if you observe the slope, that is slope is less than 90 degree. So less than 90 degree means tan values positive. Okay, theta less than 90 degree, that is tan theta positive. Tan theta positive means slope positive. Okay, slope positive. Slope positive means velocity positive. So here velocity first A, velocity positive. Okay, velocity positive. Third point, as time increases, okay, time increases. So the slope at the tangent, at the slope at the point for the time t1 and t2, you observe the slope for time t1 and t2. The slope for time t2 is greater than the slope of the tangent at t1. So okay, as time increases, slope, okay, you look at the graph, that is slope increases. Time increases means slope also, that is the slope of the tangent at t1 is less than the slope of the tangent at t2. So at time increases, slope increases. Slope increases. So in tan theta value, that is in positive side, as the angle value increases, tan theta value also increases. Okay, tan theta increases. Tan theta increases. Tan theta increases means velocity increases. Velocity increases. Okay, so tan theta velocity positive, increasing. Okay, so here what about the acceleration? In this case, acceleration. So as velocity increases, acceleration also increases, because velocity increases means it is a accelerated motion. It is a accelerated motion. Okay, it is a accelerated motion. So what is the direction of the acceleration? So acceleration is also in the direction of the velocity in this case. Okay, so it is an acceleration. Velocity increases means acceleration is also in the direction of the velocity. So acceleration positive. Okay, so velocity increasing, so it is an accelerated motion. Acceleration is also in the direction of the velocity. So acceleration positive. Clear? Okay. Then the next case, next velocity positive decreasing. So it is the displacement time graph. So this is the curve for, so this point T1, T2. theta 1, theta 2. Okay. So what are the conclusions we can make from this graph? 1. Concave downwards. Concave downwards. 2. Theta, here also theta less than 90 degree. Okay, less than 90 degree. So theta less than 90. Okay, theta less than 90. That is tan theta positive. Tan theta positive means slope positive. Slope positive means velocity positive. Velocity positive. Second case, velocity. Yes, we got velocity positive. Okay, velocity positive. Third point, as time increases, okay, time increases. So if you look at the graph, time increases, the slope of the tangent at t1 is greater than the slope of the tangent at t2. As time increases, slope decreases. Slope decreases. Okay? Slope decreases means tan theta, okay, angle value decreases means in the positive side. Decreases means tan theta value decreases. So tan theta decreases. Tan theta decreases means velocity decreases. Okay, velocity decreases. So velocity positive and decreasing. So what about the acceleration here? Acceleration. So velocity decreases. Velocity decreases means it is a decelerated motion. Okay, decelerated motion or retarded motion. Retarded motion. Okay, retarded motion. So retarded motion means velocity in this direction, acceleration in this direction. So here velocity is positive, so acceleration is opposite to velocity. So acceleration is negative. Okay, acceleration negative. Acceleration negative. So velocity, so decelerated motion, velocity in this direction, acceleration in this direction. Here velocity is positive, so acceleration should be negative. Okay, should be negative. Okay. Then the third case, next case, velocity negative increasing. Displacement time graph, displacement time. Okay, displacement time. T1. T2. So this is theta 2. So what are the conclusions we can make? One, concave upwards, sorry, concave downwards. Concave downwards. 2. So the theta values greater than 90 degree. Okay, theta greater than 90 degree. So tan theta value. So greater than 90 degree means tan theta negative. Tan theta negative. Tan theta negative means slope negative. Slope negative means velocity negative. So velocity C, velocity negative. Third point, as time increases, slope decreases. So look at the graph. So the slope of the tangent at T1, okay, T1 is greater than the slope of the tangent at T2. So this line is more steeper, okay, more steeper. So slope increases. So slope decreases. So in the negative side, if the negative side, the angle value decreases means tan theta value increases. Okay, slope in the negative side here. Okay, so the angle value decreases means tan theta value increases. So slope decreases, therefore tan theta increases. So therefore velocity increases. Okay, velocity increases. So that is negative increasing. So as time increases, slope decreases. Okay, slope decreases. So slope decreases means the negative side. Okay, slope decreases means tan theta value increases. Okay, tan theta value increases. Tan theta value increases means velocity increases. Okay, velocity increases. So therefore velocity negative increasing. Okay, so what about the acceleration here? So in the negative side velocity is increasing. So velocity is increasing means it is a accelerated motion. It is a accelerated motion. So what is the direction of the acceleration? Acceleration is also in this direction of the velocity. Okay, velocity. So acceleration negative. Okay, acceleration negative. Okay. So velocity negative and increasing. Okay, increasing. Okay, the last case, velocity negative decreasing. So displacement time graph. Always like this. Okay. t1 t2. Curl is like this. So what are the conclusions we can make? One, that is concave upwards, concave upwards. Two, theta greater than 90. So the angle made by the tangent with the horizontal x-axis. Okay, so theta greater than 90, tan theta negative, slope negative, velocity negative. So D, velocity negative. Third point, as time increases, okay, time increases, so the slope of the tangent at a time t1 is less than the slope of the tangent at t2, or otherwise we can say slope of the tangent at t2 is greater than the slope of the tangent at t1. As time increases, slope increases. So in negative side, if the slope increases means that is greater than 90 degree, if the slope increases means tan theta value decreases. Okay, slope increases, tan theta decreases. Tan theta decreases means velocity tan theta decreases, velocity decreases. Okay, velocity decreases. So negative decreasing. Okay, negative decreasing. So what about the acceleration here? Acceleration. So velocity decreases means it is a decelerated motion. So retarded motion. Okay, velocity negative, retardation means in this direction. So acceleration in this direction. Velocity is negative, it is a retarded motion. So acceleration is opposite to the direction of the velocity. So velocity negative, acceleration positive. Acceleration positive. Kadam. Acceleration positive. So these are the 4 cases. So the curves, that is curves shape is very important. So velocity positive increasing, velocity positive decreasing. Okay, velocity negative increasing, velocity and negative decreasing. Okay, decreasing. Quick recap, that is a quick glance of these 4 graphs, that is displacement time graph, displacement time, displacement time, displacement time, displacement time. So the first curve is second curve, third curve, fourth curve. Nice. Here velocity positive increasing, acceleration positive. Okay, acceleration positive. Velocity positive decreasing, velocity positive decreasing, acceleration negative. Okay, velocity negative increasing, acceleration negative. Velocity negative decreasing, acceleration positive. Acceleration positive. Okay, clear? So the next is velocity time graph. So far we have discussed a displacement time graph. So velocity time graph. Okay, velocity time graph. So consider a velocity time graph. Velocity time. Okay. So the graph makes an angle theta with the x-axis. Okay. So slope of this curve, slope is equal to tan theta is equal to y2 minus y1, that is perpendicular by base, that is x2 minus x1. So that's equal to in y-axis, that is velocity v2 minus v1, t2 minus t1. So that's equal to change in velocity, that is delta v, change in time, that is delta t. So change in velocity divided by change in time, change in velocity by change in time, so that is acceleration. So that's equal to acceleration. Acceleration. So the velocity, the slope of the velocity time graph, slope of the velocity time graph gives the acceleration. So slope of the displacement time graph gives the velocity. So slope of the velocity time graph gives the acceleration. Okay, acceleration. So case 1. Case 1, uniform motion. Uniform motion. So velocity time graph. So at time t1 it has a velocity, okay, t1. t2 it has the same velocity, okay, that is uniform motion. So t1, so velocity is constant. Uniform motion means velocity is equal velocity constant. So at a time t1 it has a velocity, t2 has the same velocity. So this is the graph. So what about the acceleration? Acceleration is the slope of the velocity time graph. What is the slope of this curve? That is slope is equal to 0. Tan theta is equal to 0. Therefore acceleration is equal to 0. So acceleration is equal to dv by dt. So velocity constant. So acceleration is equal to 0. Okay. So then non-uniform motion. Case 2, non-uniform motion. Non-uniform motion. Non-uniform motion means velocity increasing or velocity decreasing. Okay, decreasing. Okay. So first velocity time graph. So as time increases, velocity increases. Okay, velocity increases. So what is the theta? Theta. So acceleration is nothing but the slope of the velocity time graph is acceleration, gives the acceleration. So theta less than, here theta less than 90 degree. So tan theta positive, slope positive. So acceleration positive. Acceleration positive. Okay, acceleration positive. So if you find the slope at each and every point of this curve, that is, we can see that slope is also constant. Slope is also constant. Okay, so therefore acceleration is equal to acceleration constant. Okay, so it is an accelerated motion. Okay, accelerated motion, that is constant acceleration. Constant acceleration. Okay. So then if the velocity decreasing, as time increases, so consider the velocity time graph. Okay, velocity time graph. As time increases, velocity decreases. Okay, velocity decreases. Velocity decreases. Velocity decreases. So theta. So theta greater than 90. Okay, theta greater than 90. So tan theta negative, slope negative, slope negative. The slope of the velocity time graph gives the acceleration. So acceleration negative. Acceleration negative. Okay, negative. So acceleration negative means it is retardation. Okay, retardation. Okay, retardation. So if you find the slope at each and every point, so okay, so theta. Okay, so slope is constant, so acceleration is also constant. So constant retardation. Okay, constant retardation. Okay, then consider the velocity time graph. Velocity time graph. Horizontal straight line, that is, velocity is constant. Okay, velocity is constant. T1, T2. Okay, so A, B, C, D. Okay, so this is a velocity time graph. So this is the time T1 and T2. So we have to find the area under the VT graph. Area under the VT graph between the time T1 and T2. T1 and T2. So that's equal to area of the, it is nothing but area of the rectangle. Okay, area of the rectangle ABCD, area of the rectangle ABCD, clear? Area of the rectangle ABCD. So that's equal to area of the rectangle, length into breadth. Okay, length into breadth, that is AC into, that is CD, length into breadth, AC into CD. So what is AC? So that is velocity. Okay, so what is CD? That is T2 minus T1. So that's equal to V into velocity V, that is T2 minus T1, that is time. That's equal to velocity into time. Okay, velocity into time. So velocity, so we know the relation, that is velocity is equal to displacement by time. So velocity into time is equal to displacement. Okay, displacement. That is very, very important. So the area under the velocity time graph gives the displacement. Okay, displacement. So very, very important. Area under the velocity time graph gives the displacement. Okay. So slope of ST curve, ST curve, what? Velocity. Slope of VT curve, acceleration. Area under VT curve, that is displacement. So first problem, so consider a displacement time graph. Done. Five, 15, 25. Okay. So O, A, B, C. So find the velocity, in the region OA, AB and BC. Okay, BC. So a displacement time graph is given like this. So we have to find the velocity in the region OA, AB and BC. So dear students, we know that the slope of the displacement time graph gives the velocity. So first I am considering the region, that is OA. Okay. So the slope formula, what is the formula? So velocity is nothing but the slope of the displacement time graph. So V is equal to, what is the formula? That is Y2 minus Y1 divided by X2 minus X1. Okay. So X1 Y1 X2 Y2. So OA. So here X1 Y1, that is 0, 0. A, that is X1, that is X2, that is 5, then Y2, that is 10. Okay. So that's equal to Y2 minus Y1. Y2, that is 10 minus Y1, that is 0, divided by X2, that is 5 minus 0. So 10 divided by 5, so that's equal to 2 meter per second. So that is the velocity in the region that is OA. So next I am considering the region AB. So AB, what is the slope of this line, that is AB? So it is parallel to the time axis. It is parallel to the time axis. So slope is equal to 0. So therefore velocity is equal to 0. Okay. So next I am considering the region that is BC. So velocity is equal to formula, that is y2 minus y1 divided by x2 minus x1. So x1 y1, x2 y2. So in this BC, okay, BC. So what is x1 y1? So x value, that is 15, comma y1, that is 10. In the region that is C x2, that is 25, y2, that is 0. So that's equal to 0 minus y1, that is 10, divided by x2, that is 25, minus x1, that is 15. So that's equal to minus 10 divided by 10. That's equal to minus 1 meter per second. So that is the velocity in the region. So in this line we get that is positive slope 2 meter per second. So when the line comes down, that is theta greater than 90 degrees. So in this line theta less than 90 degrees. So we get that is positive slope. So in this line, that is theta greater than 90 degrees. So we get minus slope, that is minus velocity. Okay, minus velocity. Clear? So the second question. Identify the nature of motion from the following distance versus time graphs. Identify the nature of motion from the following distance versus time graph. So consider the following distance versus time graphs. So these are the following distance time graph. Okay, distance time graph. So we have to identify the nature of motion from these following graphs. So first graph, when you consider this graph at a time t1, the body is at a particular distance. Okay, at time t2, the body is at the same distance. That means the body, as the time goes on, the body doesn't move from this from that position. That's why we can say that it is the graph of, that is, the body is at rest. Okay, body is at rest. So otherwise we can say that this line which is parallel to the horizontal axis. Okay, horizontal axis, that is the slope of the graph is 0, that is tan theta 0. So the slope of the distance time graph gives the speed. Okay, so the slope is equal to 0, therefore the speed is equal to 0. That means the body is at rest. Okay, body is at rest. So first graph, that is body is at rest. Body is at rest. Okay. 2. So this graph which inclined to the origin. Okay, origin. So it is a distance time graph. So the slope is equal to, so this graph represents the slope at every time, that is slope is constant. Okay, slope is constant. Slope is constant means that is speed is constant. That is the graph represents, that is uniform motion. Okay, uniform motion, that is speed is constant, uniform motion. Okay, so as the time goes on, that is the slope doesn't change. Slope is always constant. Slope constant means the slope of the distance time graph gives the speed. Okay, speed. So the speed doesn't change, that is a constant speed. So that means it is a uniform motion. Okay, uniform motion. So the distance at time t is equal to 0, the distance covered by the body is 0. Okay, so inclined to the origin, the graph inclined to the origin means, that is at time t is equal to 0, the distance traveled by the body is 0. Okay. So what about the third graph? Third graph. So in this graph, so if you draw the tangent, that is okay, if you draw the tangent, that is the slope that is increases. Okay, slope increases. So as the time goes on, the slope increases. So the slope of the distance time graph gives the speed. So since the slope increases means, that is speed increases. Okay, speed increases. That means that is accelerated motion. Yes, accelerated motion. Accelerated motion. Okay. So what about the fourth one? So if you draw the tangent, that is okay, that is slope decreases. Okay, slope decreases as the time goes on, that is slope decreases. Slope decreases means that is speed decreases, that is decelerated motion. Decelerated motion. Decelerated motion. So as the time goes on, that is the slope of the curve decreases. Okay, slope of the curve decreases. That is the slope decreases means speed decreases. So it is a decelerated motion. Okay. So fifth question, it is a vertical line. So, okay, vertical line. That is the slope of the, so slope of this line is, that is 90 degree. So tan 90, that is infinity. That is infinite speed. Okay, infinite speed. This graph represents, that is infinite speed of the body. Okay, it is not possible. Okay, so not possible. Okay, not possible. Then sixth one, as the time goes on, the distance covered by the body decreases. So in a motion, the distance covered by the body never decreases. The displacement may decrease, but the distance covered by the body never decreases. So this graph, that is as time goes on, the distance covered by the body decreases. So the distance in a motion, as the time goes on, the distance always increases. Okay, so it never decreases. So therefore the sixth graph, it is not possible. Not possible. Okay, then seventh one. So for a particular instant of time, so the body covers two distances. Okay, two distances. So in a particular instant of time, that is the body, it shows, this graph shows at a particular time, that is the body covers two distances. In a one-dimensional motion, that is, it is not possible. That is, the body never covers, does not cover two distances at a particular instant of time. So that's why it is also not possible. Not possible. Okay, so it shows, the graph shows at a particular instant of time the body covers two distances. Okay, so two distances. So it is also not possible. Okay, so these are the distances. So first graph, that is the body is at rest. So identify the nature of motion from the following distance versus time graph. So we have to find what type of motion the body undergoes from this graph. So the first graph represents the body is at rest, that is the body doesn't move. The second one, that is a uniform motion, the body is uniform motion, that means constant speed. So as the third motion, that is, it is an accelerated motion. Fourth graph, that is it is decelerated motion. Fifth one, that is infinite speed, not possible. Sixth one, as the time increases, distance covered by the body decreases, it is also not possible. And the seventh one, that is at a particular instant of time, which the graph shows the body covers two distances, that is also not possible. Okay. So the next is third problem. So consider a tower. A boy standing at the top of the tower projects a ball vertically upwards. Okay. So the trajectory of the ball is given in the figure. So the path followed by the ball is as shown in the figure. Okay. So we have to draw the displacement time graph for the trajectory of the ball or for the motion of the ball. Okay, draw the displacement time graph. Draw 1, 2, draw the velocity time graph. Velocity time graph for the motion of the ball. Okay, so ball is projected vertically upwards, so it reaches a particular displacement. Okay, so consider the motion of that is the point of projection as the origin. Okay, so the vertical upward direction as the positive axis and downward direction as a negative axis. Okay, negative x-axis. So this is the point of projection as origin. So upward motion in the positive axis and downward motion in the negative axis. Okay, so we have to draw the displacement time graph and draw the velocity time graph. Okay, so ball is projected vertically upwards, it goes a certain displacement, and when the velocity becomes 0, it comes down, it reaches the origin and again it reaches the ground. Okay, so that is the trajectory of the path followed by the ball. So we have to draw first the velocity displacement time graph. Okay, displacement time graph. So at a time t, it reaches this maximum height. Okay, maximum height. So at a time t, it reaches a height. Which is a height. So at a time, so when it reaches the that is original position, that is origin, that is the point of projection, that is time 2t. Okay, at time 2t, so the displacement becomes 0. That is, it comes to the original position. Okay, original position. At a time t0, at time t0, it reaches the ground. That is the negative displacement. Okay, negative displacement. So it reaches. Suppose this is the height of the tower. So height displacement in the negative direction. So height. Okay, so this is the displacement so traveled by the body. So when a ball is projected at a time t, it reaches a certain height in the upward direction t. So when time becomes 2t, that is the displacement becomes 0. That means the ball comes to the original position. And time t0, that is the ball from this mean position, that is the ball displaced, that is travels the negative displacement that is height, and it reaches the ground. So we have to find that is draw the displacement time graph. So when we draw the displacement time graph, so the slope of the graph will be like this, in such a way that so it correctly represents the velocity of motion, because the slope of the displacement time graph gives the velocity. Okay, so we have to consider the velocity of motion also. That is, when a ball is projected with a certain velocity, and when at this point the velocity becomes 0 and it comes down. Okay, comes down and it reaches the point, that is velocity becomes 0. So when it comes down, that is velocity is negative velocity. When the ball comes down, negative velocity. So negative velocity, that is velocity increases. So as the ball, when the ball is projected with the initial velocity u, as the ball goes upwards, the velocity decreases continuously. The velocity decreases. So at a particular, that is this height, that is the velocity becomes 0. So from that point it comes down. The ball comes down. That is the velocity is negative velocity that is increasing. Okay, increasing negative velocity. So throughout the motion, so from this point to this point, the velocity is negative velocity and it is increasing. So in such a manner only we have to draw the curve. Okay, so first when we draw the displacement time graph, the slope of the displacement curve, so it is like this. Okay, so from this point t, that is this point, so the velocity decreases. Okay, decreases, and at this point, that is the time t, this point the velocity becomes 0. So when you draw the tangent at this position, that is the horizontal to the time axis, so velocity becomes 0. So after that, from this point, that is the velocity is negative velocity. So throughout this point up to this point, the velocity is negative velocity, and it increases. Okay, increases. So the curve is like this. Okay, curve is like this. Okay. So when you consider the slope of the curve, so slope decreases. Okay, slope decreases. Decreases at this point, the slope becomes 0. That means the velocity becomes 0. So from this point, that is the slope increases. Okay, slope increases, but in the negative direction. So negative velocity. So up from this point to this point. Okay, it's a continuous curve. Continuous curve. So the velocity is negative velocity. Okay, negative velocity. So when we study the theory, that is, so the curve is like this, that is positive velocity, positive velocity, the velocity is positive decreasing, velocity is positive decreasing. Okay, decreasing. So when the curve is like this, so that is velocity is negative increasing, velocity is negative increasing. So that is this portion of the curve. ठीक है? Okay. So next is draw the velocity time graph. Velocity time graph. Velocity time graph. So the ball is projected with a certain velocity, initial velocity. As the ball goes on, that is goes upwards, the velocity is continuously decreasing. Okay, decreasing. At this point, the velocity becomes 0. Okay, 0. So when it comes down, that is negative velocity. Okay, when the ball comes down, negative velocity. So at this point, that is time t, 2t. Okay, 2t. This is the time t. This is the time 2t, and this is the time, that is when the ball reaches the ground, that time, that is t0. Okay, t0. So from this point, the velocity increases in the negative direction. That is negative velocity. It is increasing. When the time t0, it reaches the ground. So the curve is like this. Curve is like this. Okay, so it has a certain velocity, initial velocity. So initial velocity. So when the time goes on, the velocity decreases. Okay, velocity decreases. At this point, that is the velocity becomes 0. What is this time? That is t. Okay, t. So after that, the velocity in the negative direction. Okay, negative velocity. So this is the velocity at time 2t. Okay, 2t. And this is the velocity, that is when the ball reaches the ground, that is t0. Okay, t0. Okay, so this is the velocity time graph. So the ball is projected with initial velocity, that is this velocity. So as the time goes on, the velocity decreases. Okay, velocity decreases. When the time becomes t, that is the velocity becomes 0. Okay, so 0. So and after that, the velocity is negative. When the ball comes down, it is a negative velocity. So negative velocity, the velocity is going in the negative direction. Okay, so negative. So at a time 2t. Okay, so it has the velocity that is as that of u. That is, this velocity is u. This also u. So the initial velocity. So at a time t0, it reaches the ground. Okay, ground. So this is the velocity time graph for the trajectory of the ball. So clear? So fourth problem. So the displacement time graph of two particles A and B. The displacement time graph of two particles A and B are straight lines. which are inclined with the time axis of angle, it is A, that is 30 degree, that is 60 degree. So the displacement time graph of two particles A and B, so which inclined with the time axis with the angle that is 30 degree and 60 degree. So what is the ratio of, velocities of A and B? Okay, A and B. So option A 1:√3, option B √3:2, option C √3:2, option D 1:3. So the displacement time graph of two particles A and B is given, that is which are inclined with the time axis, that is 30 degree and 60 degree. Okay, 60 degree. So they are straight lines which are inclined with the time axis of angle 30 degree and 60 degree. So what is question is asked, that is you have to find what is the ratio of the velocities of A and B. So the option A 1:√3, B √3:2, C √3:2, and option D, that is 1:2. So velocity of A is equal to, that is tan theta. Okay, tan theta. So that's equal to, what is the angle of inclination, that is 30 degrees. So tan 30. So that's equal to 1/√3. So VB is equal to tan 60. Okay, tan 60. So that's equal to √3. Okay, √3. So we have to find, that is VA is to VB, that is the ratio of the velocities of A and B. So that's equal to 1/√3 divided by √3. So that's equal to 1/√3 into 1/√3. So that's equal to 1/3. So that is nothing but 1:3. So option D is the answer. Okay, option D is the answer. 1:3. So fifth problem. So this is the displacement time graph. Displacement time graph. So 10, 5. So what is the, find the equivalent velocity time graph. Find the equivalent velocity time graph. ठीक है, velocity time graph. Option A option A 2, option B 2, option C -2. Okay, option D it is velocity time graph. Okay, velocity time graph. So velocity time graph. Velocity time graph. Option D here. Okay, option D. -2. So this is a displacement time graph. What is its equivalent? Velocity time graph. Velocity time graph. So we know that the slope of the displacement time graph gives the velocity. Okay, velocity. So the slope of this curve, that is theta. Okay, theta. Theta greater than 90 degree. Okay, theta greater than 90 degree from this graph. So tan theta negative. Okay, tan theta negative, slope negative, velocity negative. Okay, velocity negative. So from this graph, so the slope of the graph is, that is greater than 90 degree. So 90 degree means that is velocity negative. So here option, that is velocity positive. So this is not the option. So velocity is positive here. So here also velocity is positive. So therefore these two options are not the answer. Okay. So when considering these two options, okay, these two options, this option velocity is negative, this option also velocity is negative. Okay, this graph shows velocity, negative velocity. So this or this. So from this displacement time graph, that is when you find the slope at each and every point, that is the slope is constant. Okay, slope is constant. So that means velocity is constant. Okay, velocity is constant. So negative. So each and every point the slope is constant. So straight line graph. Okay, so the velocity is constant. So negative, constant. So which one? So this one, that is as time increases, velocity increases in the negative direction. Velocity time. Okay, as time increases, that is velocity also increases. Here, that is the velocity is, as time increases, that is the velocity is constant. Okay, velocity is constant. So therefore this is the answer. Okay, this is the answer. So it is, how it is -2. So from that graph, that is slope is equal to slope of the displacement time graph gives the velocity. So velocity is equal to y2 minus y1 divided by x2 minus x1. Okay, so x1 y1, x2 y2. Okay, so this one, x1 0, y1 that is 10. Okay, so this point x2 that is 5, y2 that is 0. So substitute the values. So y2 that is 0, 0 minus y1 that is 10. Okay, divided by x2 that is 5, 5 minus x1 that is 0. So that's equal to minus 10 divided by 5, that's equal to -2. So that's equal to -2. So that is the answer. Okay. Sixth problem. So consider a displacement time graph. Displacement time graph. Displacement time graph. So find the equivalent velocity time graph. Velocity time graph. Option A. Option B. Option C. Option D. Option D. So velocity time. Velocity time. So the displacement time graph is given. Okay, displacement time graph is given. So we have to find the equivalent velocity time graph. Okay, velocity time graph. So when we discuss the theory, that is we have seen that is 4 types of graph, that is okay, 4 types of graph. This is velocity positive increasing, velocity positive decreasing. Okay, so this graph, that is velocity negative increasing, velocity negative decreasing. Okay, so we can divide our graph, that is a displacement time graph, into that is 2 sections. So okay, 2 sections. So like this, the first part is like this. So this graph, okay, this part, okay, this part. So it is velocity positive. If the curve is like this, that is concave downwards, that is velocity positive decreasing, So first part. So at this part, that is the tangent. If you draw the tangent, that is, it is horizontal to the, so it is parallel to the time axis. Okay, so the slope is equal to 0. Okay, slope is equal to 0, therefore velocity is equal to 0 at this part and this part. Okay, this part. So this is, so velocity negative increasing, Now we compare the options. Okay, so total displacement time graph. So we convert, that is split into 3 portions. The first portion, So this portion and this portion. Okay. So this portion resembles this portion. Okay. So this portion we have seen, that is when we discuss the theory, we clearly discuss, that is velocity positive decreasing, velocity positive decreasing. So at this portion, if you draw the tangent, so in this point, so that is parallel to the time axis, so slope is equal to 0, therefore velocity is equal to 0. And this portion, so this portion resembles this graph. So this is velocity negative increasing, velocity negative increasing. Now you compare the options. So in this graph, so first velocity positive here, so velocity decreasing. Okay, velocity decreasing, clear. So velocity becomes 0. In this point, velocity becomes 0. Again, the velocity positive. Velocity positive. So therefore, this is not the option. So in this option, velocity is 0 and velocity positive increasing. Positive increasing. So this is not the option. So here, initially the velocity is negative. So it is not the option. So when you come to this option, that is first velocity positive. Okay, velocity positive decreasing. So when it comes down, that is velocity decreasing. So at a particular point, that is velocity becomes 0. So in this, that is velocity negative. So in this portion, from this point to this point, that is velocity positive. Velocity positive decreasing up to this point. Then this point, that is velocity becomes 0. Here velocity becomes 0. So after that in this portion, that is velocity is negative, that is as time goes on, that is velocity increasing. So velocity negative, so here this one, velocity negative increasing. So negative increasing. So this option is the answer. Clear? So velocity positive decreasing. So in this portion, velocity becomes 0, that is this point, velocity becomes 0. So in this portion, that is this portion, velocity negative, so negative, then increasing. So as time goes on, velocity increasing, negative portion is increasing. So that is the answer. Clear? So the seventh problem. So a speed time graph of a particle's motion, which is moving in a fixed direction, is given. Okay. So speed time graph. Speed time graph. So speed time graph. Okay, speed time graph is given. Find the displacement so find the distance traveled by the body. Distance traveled by the body between 0 and 10 second. 1. 2. Find the average speed of the body. Find the average speed of the body. Find the average speed of the body in the same interval. Body in 0 to 10 seconds. 10 seconds. Okay, 10 seconds. So we know that the area under the speed time graphs gives the distance. Okay, so the distance traveled by the body is nothing but the area under the triangle, that is 0 to 10 seconds. So the area under the triangle OAB. So this area gives the distance traveled by the body between the time interval 0 to 10 seconds. So distance equal to area of the triangle, OAB. So that's equal to half into 10 into, that is height, that is 12. Okay, so 2 5 times, that's equal to 60 meter. Okay, 60 meter. That is the distance traveled by the body in the time interval 0 to 10 seconds. The second one is find the average speed of the body in the same time interval 0 to 10 seconds. So average speed is equal to distance covered by the body, that is total distance divided by total time. Okay, total distance covered by the body divided by total time. So that's equal to total distance covered by, that is 60. What is the time? That is 10. So 0 0 cancel, that's equal to 6 meter per second. So that is the average speed of the body. Clear? So velocity as speed time graph is given. So we have to find the distance traveled by the body between the time interval 0 to 10 seconds. So the speed of the area under the speed time graph gives the speed. Okay, so the area under the speed time graph gives the distance. So this is the speed time graph. So area under, that's nothing but the area of the triangle. Okay, area of the triangle OAB. So that's equal to half into 10 into, that is 12. Okay, that is equal to 60 meter. So average speed is equal to, we know the formula, that is total distance covered by the body divided by total time. So that is equal to 60 divided by, so 60 meter divided by total time, that is 10. So that's equal to 6 meter per second. So 8th problem. A car which is at rest, okay, that is u is equal to 0, okay, which is at rest, accelerated with a constant acceleration a, okay, constant acceleration a, and it reaches a maximum velocity, that is Vm, okay, constant velocity Vm. So after that, in time t1, so after that it decelerated, okay, decelerated with the same acceleration, that is constant acceleration a, and after time t2, so the car becomes rest, that is v is equal to 0. So find, suppose the distance covered by the car, okay, distance covered by the car is capital L, okay, capital L. Find the time of journey. Find the total time of journey. So a car which is at rest, that is u is equal to 0, is accelerated with a constant acceleration a, After time t1 it reaches a maximum velocity, Vm. Okay, so after that it is decelerated with the constant acceleration a, and after time t2 it comes to rest. Okay, rest. So we have to suppose capital L is the total distance traveled by the car. We have to find the total time of journey. Okay, so I am going to draw a graph. So using graphical method we are going to find the total time of journey. Okay, so I am going to draw the velocity time graph for the journey of the car. Velocity time graph. Okay, so velocity time graph. So at time t is equal to 0, the car starts from rest, that is velocity is equal to 0. Okay, velocity to constant acceleration. Okay, constant acceleration. So after time t1, so it reaches a maximum velocity Vm, that is Vm. Okay, so after that it decelerates after time t2 it comes to rest, that is velocity 0. So that is the displacement time graph, velocity time graph of the car. Okay, a car starts from rest, that is initial velocity 0, at time t is equal to 0, initial velocity is 0. So after that it accelerates with the constant acceleration after time t1 it reaches a maximum velocity Vm. Okay, so after that from that point it starts to decelerate with the constant acceleration, that is a. After time t2 it comes to rest. Okay, so we have to find the total time of journey. So we know that the area under the velocity time graph gives the displacement. Okay, displacement. So area under this triangle. So area under this velocity time graph is nothing but the area under this triangle. Okay, triangle. Okay. So the distance traveled by the car, so distance is equal to area of the triangle, that is OAB. Okay, that is area of the triangle OAB. So that's equal to half into base, that is t1 plus t2 into, that is height, that is Vm. Okay, Vm. So in the question it is given the total distance traveled by the car is capital L. So L is equal to half into V1 plus V2 into Vm. Okay, so we have to find, not V1 plus V2, that is T1 plus T2. So we have to find the total time of journey. It is nothing but T1 plus T2. Okay, T1 plus T2. So T1 plus T2 is equal to 2L divided by Vm. So that is the total time of journey of the car. Okay, T1 plus T2 is equal to 2L by Vm. Clear? So the next is the 9th problem. Consider a velocity time graph. Okay, consider a velocity time graph. A train starts from rest and it is accelerated at a time that is 10 seconds, it reaches a constant velocity. Okay, constant velocity 30 meter per second. From 10 to 20 seconds, it runs with the constant velocity, that is 30 meter per second, and after that it starts to decelerate. At a time t is equal to 32 seconds, it comes to rest. So find the distance traveled by the train. Distance traveled by the train. Okay, find the distance traveled by the train. Option A, 630 meter. Option B, 620 meter. Option C, 1200 meter. Option D, 500 meter. Okay, a train starts from rest and it is accelerated through a constant acceleration. At a time t is equal to 10 seconds, it reaches a constant velocity, that is 30 meter per second. From 10 to 20 seconds, it runs with the constant velocity, that is 30 meter per second, and after that it starts to decelerate. Okay, decelerate, and at the time t is equal to 32 seconds, it comes to rest. So we have to find the total distance traveled by the train. So the distance traveled by it's a velocity time graph. So the area under the velocity time graph gives the distance. So distance equal to area of OAE, that is the triangle. Okay, OAE, triangle OAE, plus area of the rectangle ABED. Okay, ABED, plus again the area of the triangle BCD. Okay, BCD. So that's equal to half into area of the triangle OAE, half into 0 to 10, that is 10 into height, that is 30, plus area of the rectangle 10 to 20, so 10 into 30. Okay, plus area of the triangle BCD, so half into 20 to 32, that is 12 into 30. Okay, so that's equal to 5, so 150, plus 10 into 30, that is 300, plus 6 times, so plus 180. Okay, so 300, 180, 150, so 314, 5, 6, so 630 meter is the answer. 630 meter. So the next is 10th problem. Which of the following curve does not represent the motion in one dimension? The motion in one dimension. Option B, so velocity time graph. So which of the following curve does not represent the motion in one dimension? So in one dimensional motion, at a particular instant of time, the body has only one velocity. Okay, So in two-dimensional motion, that is the projectile motion, the body have two types of, at a particular instant of time the body has two types of velocity, that is the body undergoes two types of velocity, that is one is the horizontal velocity, another one is the vertical velocity. Okay, the body undergoes in projectile motion. So in this next chapter we will discuss projectile motion, that is motion in a plane, motion in two dimensions. So in this chapter we are only concentrating on motion in one dimension. Okay, one dimension, that means the body at a particular instant of time, the body has only one velocity, the body undergoes only one velocity. So in projectile motion the body undergoes two types of velocity, that is horizontal velocity and vertical velocity. Okay, vertical velocity. So when this curve, that is at each and every that is instant of time, the body has only one velocity. Okay, only one velocity. So here also the body has at a particular instant of time only one velocity. So in this curve also, that is at a particular instant of time the body has only one velocity. So but this curve that is at a particular instant of time, okay, instant of time, the body has two velocity. Okay, two velocity. It is not possible in one dimensional motion. So this is the answer. Which of the following does not represent? So this is the answer. Does not represent the motion in one dimension. So in one dimension, at a particular instant of time, the body has only one velocity. In projectile motion, in two-dimensional motion, the body undergoes horizontal velocity and vertical velocity. So in that, the body has two types of velocity. Okay, two types of velocity. So problem: a car starting from rest accelerates at the rate f through a distance s, then continues at a constant speed and then decelerates at the rate f by 2 to come to rest. The total distance travelled is 15s. Then, so listen here, these are the four options given for this question. S is equal to ft, S is equal to 1 by 6 ft square, S is equal to 1 by 72 ft square, and S is equal to 1 by 4 ft square. So what is given in the question? That is a car starting from rest. Okay, that is the initial velocity of the car is 0 and it moves with the constant acceleration f for a distance s. Then it starts with the car starts from rest and moves a distance s with a constant acceleration f. And after that it moves with it attains a constant speed, and after a particular time interval the car moves with a constant speed. Okay, constant speed. So after that the car starts to decelerate at the rate f by 2 to come to rest. So after that the car starts to decelerate, okay, with a constant deceleration f by 2, and finally the car comes to rest. So the total distance travelled is 15 years. Means that is the total journey of the car we can divide it into three parts. So the first part of the motion is accelerated motion, second part of the motion, that is the car moves with a constant speed, and third part of the motion, that is the decelerated motion. Okay, decelerated motion. So altogether the accelerated motion, constant motion and decelerated motion, the car have travelled the distance, that is 15 years. Okay, so we have to find the distance, that is yes, in terms of that is acceleration and time. Okay, acceleration and time. So what I am going to do for this question, that is I am going to draw the velocity time graph for this motion of the car. Okay, velocity time graph. Okay, this is a velocity time graph. Velocity time graph. So we know that the slope of the velocity time graph gives the acceleration, the area under the velocity time graph gives the displacement. Okay, displacement. So the car starts from rest and moves with moves with the constant acceleration f for a distance s. That is the slope of the curve, that is f. Okay, so the area under the velocity time graph, it is distance, the car have moved the distance. So after time t1, so it reaches a constant speed. Okay, it reaches a constant speed v. Okay, constant speed v. So after that the car continues at a constant speed. Okay, constant speed. Constant speed means acceleration 0, that is straight line. Okay, straight line. That is for a time t. Okay. So after that the car starts to decelerate with a constant deceleration f2 and come to rest. Come to rest. So the constant deceleration, that is f by 2. So deceleration f by 2, that is the slope is double the slope of the first slope. Okay, f by 2. f by 2. So here the slope is double the slope. Okay. That is for the initial first part of the journey the car has taken the time t1. So here it moves with a deceleration f by 2. So how much time the car has taken? That is the time 2 t1. Okay, 2 t1. So in time t1 it moved the distance s. In time t1 how much distance it will travel? That is 2s. 2s. Okay. So what is the distance traveled by the car with a constant speed? Because it is the question it is given, that is the total distance traveled is 15 years. So in accelerated motion and decelerated motion the car has traveled the distance, that is 3 years. So 12 years, 15 years minus 3 years, that's equal to 12 years. So the car has moved with the distance, that is 12 years with the constant speed. Okay, constant speed. So clear? Then for the first part of the motion, that is accelerated motion, I am using the equation, that is v square minus u square is equal to 2as. Okay, so it reaches a constant speed, that is the final velocity. So the car starts from rest, that is initial velocity is 0. 2, what is the acceleration here? F. So yes. So v square is equal to 2fs. So v is equal to root of 2fs. V is equal to root of 2fs. Then next I am considering the second part of the journey, that is the car moves with a constant speed. Okay, moves with a constant speed. So velocity is equal to displacement by time. So displacement is equal to velocity into time. So what is the displacement mode, that is the car moves, that is 12s. 12s equal to, so what is the velocity? The car moves with the constant velocity, that is v. So how much time? That is t. Okay. So that's equal to, instead of v is substitute, that is root of 2fs, that is into t. So 12s equal to root of 2fs into t. Squaring on both sides, that is 144 s square is equal to 2fs t square. Okay, t square. So s cancel, 2 144 cancel, that is 7 2. Okay, so s is equal to 1 by 72 f t square. So that is the answer. S is equal to 1 by 72 f t square. So compare the options. So s is equal to f t, s is equal to 1 by 6 f t square, s is equal to 1 by 72 f t square. So that is the answer. So clear? So 12th question. So this is the velocity time graph given. Okay, velocity time graph of a motion of a body, linear motion of a body. Okay, so find the body find the displacement of the body, displacement of the body, find the displacement of the body in 5 seconds. Okay, 5 seconds. So we know that the area under the velocity time graph gives the displacement. Okay, displacement. So we have to find the displacement traveled by the body in 5 seconds. So 5 seconds means, so the area under this triangle, that is OAB, and the triangle, that is BCD, and the rectangle DEFG. Okay, DEFG. So the total area under this triangle and this rectangle will give the displacement traveled by the body. Okay, first consider that is triangle OAB. Okay, OAB. So what is the area? That is half into 1, 2, 3. Okay, base, that is 3 into what is the height? That is 2. Okay, so 2 cancel, that's equal to 3 meter. Then consider the triangle, that is BCD. Okay, BCD. So what is the area? That is half into base, that is 1 into height, that is -2. That is negative displacement. Okay, negative displacement. Negative velocity, that is negative displacement. That is the body comes back. Okay, comes back. So 2 cancel, that's equal to -1 meter. Then consider the rectangle, that is DEFG. Okay, so what is the area? That is length into breadth, that is DG into DE. Okay, DE. DG, that is 4 into 5, that is 1 into DE, that is 1, that's equal to 1 meter. Okay, so the total displacement traveled by the body, that is 3 plus 3 minus 1. Okay, -1 plus 1. So -1 cancel, that's equal to 3 meter. So 3 meter is the displacement traveled by the body. Clear? So 13th problem. A body is at rest at x equal to 0 at a time t is equal to 0. It starts moving in the positive x direction with a constant acceleration. At the same instant, another body passes through x equal to 0, moving in the positive x direction with a constant speed. The position of the first body is given by x1 of t after time t, and that of second body x2 of t after the same interval. Which of the following graph correctly describes x1 minus x2 as a function of time? So in this question, the 4 options are given. So we have to clearly identify the x1 minus x2 versus time. So the motion of two bodies given. The first body starts from rest. Okay, starts from rest and moving with a constant acceleration. So the position of the first body, that is x1 of t after time t. So the position of the body is, first body is x1 of t and the second body is x2 of t. So first body, it starts from the origin and moving with a constant acceleration. So the position of the body, that is we can find with the equation s is equal to ut plus half at square. Okay, so the initial velocity is equal to 0, origin starts from rest, so initial velocity is 0. So position of the first body s is equal to half at square. So x1 of t is equal to half at square. So at the same instant of time, another body moving through the origin, moving through the origin, that is x equal to 0 with a constant velocity v. So the position of the body after time t, how we can find out, that is equal to vt. Okay, vt. So we have to find x1 minus x2. So x1 minus x2 is equal to half at square minus vt. Okay, so we have to plot, if we plot the graph, that is x1 minus x2 and t, which one of the following graph, that is 4 graph, is the answer. Okay, so the position of the two bodies, that is x1 minus x2, is given by the equation, that is x1 minus x2 is equal to half at square minus vt. Suppose time t is equal to 0, time t is equal to 0, that is x1 minus x2 is equal to 0. x2 is equal to 0. So the given graph, all the 4 graphs starts from the origin, that is x1 minus x2 is equal to 0. So from that we can identify the answer. Okay. So all the for the given 4 graphs starts from the origin, that is so we can't identify the answer. Suppose x1 minus x2 half at square minus vt. So it is the function of time. Okay, function of time. So suppose I am finding the instantaneous slope, that is the dx by dt. Okay, dx by dt is equal to half into 2 into at. Okay, at minus v. Okay, minus v, dx by dt, that's equal to half into 2at minus v. So okay, 2 get cancelled, that's equal to at minus v. Okay, at minus v. So at time t is equal to 0, dx by dt is equal to minus v, that is slope is negative. At a time t is equal to 0, slope is negative. Okay, slope is negative from this graph. So draw the tangent at a time t is equal to 0. So this is 0, so draw the tangent here. Okay, draw the tangent here. So it gives the positive slope, a positive slope. At this point, draw the tangent. So here the slope is positive slope. At this position, draw the tangent. Here also the slope is positive. So at the time t is equal to 0, that is like this. So here the slope is greater than 90 degree. So greater than 90 degree. So here the slope is negative. Slope is negative. Okay, negative. So here this graph, that is at a time t is equal to 0, slope is positive. Here also slope is positive. Here also slope is positive. For this curve, that is slope is negative. Okay, slope is negative. Negative. Okay, so this graph should be the answer, that is x1 minus x2 is equal to, so option C is the answer. Okay, C is equal to answer. So 14th question. Okay, so consider an acceleration time graph. So consider the acceleration time graph. Acceleration time graph. Okay. Suppose the body, if the body starts from rest, how much distance it will travel? How much distance it will travel? It will travel before it comes to rest. It comes to rest. So suppose the body starts from rest, how much distance it will travel before it come to rest? So this is the acceleration time graph. So from the acceleration time graph we can't find the distance traveled by the body. So we can find the distance traveled by the body from the velocity time graph. So what we are going to do is, we are going to draw a velocity time graph for this acceleration time graph. Okay, acceleration time graph. To velocity time graph. So from the acceleration time graph, so the body starts from rest. Okay, starts from rest. It moves with a constant acceleration too. Okay, constant acceleration for the time first 2 seconds. For the time 2 seconds, it moves with a constant acceleration. Okay, constant acceleration. So the body starts from rest means it, from the origin we can start the velocity time graph. Okay, for the time 2 seconds, how much velocity it travel, that is we can use the equation, that is v is equal to u plus at, because the body moves with the constant acceleration. Okay, constant acceleration. So v is equal to, if the body starts from rest, that is u0, that is 2 into, for the time 2 seconds, 2. So that is equal to 4 meter. Okay, 4 meter. So the body starts from rest. So for the time 2 seconds, the body traveled 4 meter. 4 meter. ठीक है? Next, from 4, next 2 seconds, from time 2 to 4 seconds, the body moved with the acceleration 1. So that is 1 meter per second square. So 2 to 4 seconds the body moved the acceleration, that is 1 meter per second square. So velocity, so v is equal to u plus at. So v is equal to initial velocity, that is from this point the velocity is 4. Okay, 4 plus acceleration, that is 1 into time 2. So that's equal to 6 meter. Okay, 6 meter. So for the time 4 seconds it moved with the velocity, that is 6 6 meter, right? 6 meter. So after that, the body moves with the deceleration, that is minus 1.5. That is, the body moves with the deceleration. So in the question it is given, if the body starts from rest, how much distance it will travel before it comes to rest. Finally, the body comes to rest. Okay, it is given in the question. So in what time? So we have to find at what time the body comes to rest. Okay, comes to rest. So again we are using the equation V is equal to U plus AT. So finally the body comes to rest. So therefore the final velocity is 0. Initial velocity from 6 onwards the body starts to decelerate. So initial velocity is 6 plus the body moves with the deceleration, that is minus 1.5 at the time. So time we have to find out. Okay. So minus 1.5 into minus 6. So minus 1.5 t. So minus cancel. T is equal to 6 divided by 1.5. That's equal to 4. So the body at the time, that is 4 seconds, starts to decelerate, and finally it comes to the rest at 4 seconds. That means 4 to 4. Therefore at 8 seconds the body comes to rest. So that is the velocity time graph. So this velocity time graph gives the displacement traveled by the body. So the area under the velocity time graph, gives the displacement traveled by the body. So the entire area. So this triangle. So first, second triangle, this rectangle 3, again this triangle. So this much area gives the distance traveled by the body. So first triangle. So first. Okay. So what is the area? Half into 2 into 4. 2 get cancelled. So that's equal to 4 meter. Then second triangle. Okay. Second triangle. So half into 2 into 2 into 2. So 2 get cancelled. That's equal to 2 meter. Okay. So third rectangle. Okay. Third rectangle. So 2 into area. 2 into 4. So that's equal to 8 meter. Then again fourth triangle. Okay. 4 to 8. That's half into 4 into 6. So 2 get cancelled. That's equal to 12 meters. So the total distance traveled by the body. So distance equal to 4 plus 2 plus 8 plus 12. So 12 plus 8, 20, 24, 2. That is 26 meter. 26 meter. So 15th question. A train starts from a station. Okay. A train starts from a station A and moves with a constant acceleration A1. Okay. So for it moves with a constant acceleration for some distance, and it starts to decelerate. So here it reaches a constant velocity, that is Vm, and from this point onwards it starts to decelerate with a constant deceleration A2, and it comes to rest on the station B. Okay, B. The total time taken by the train from the station A to B is, that is 4 minutes. Okay, 4 minutes. And the distance between the two stations is, that is 4 kilometer. 4 kilometer. So the distance between the two stations is 4 kilometer. Then show that show that 1 by a1 plus 1 by a2 is equal to 2. So we have to show that 1 by a1, that is the first acceleration, then plus 1 by a2, that is the deceleration, is equal to 2. Okay, so understand the question. A train starts from the station A, and it moves with a constant acceleration a1, and at a particular point it reaches a constant velocity, that is Vm. So from that maximum velocity Vm. So from that point onwards the train starts to decelerate, okay, with a constant deceleration a2, and it comes to rest on the station B. So the time taken by the train to travel from the station A to B is, that is 4 minutes, and the distance between the two stations is 4 km. Show that 1 by a1 plus 1 by a2 is equal to 2. So what I am going to, that is solution, that is draw the velocity time graph. Okay, velocity time graph. So the train starts from rest and moves with a constant acceleration, that is velocity time graph. Okay, velocity time graph. So it moves with the acceleration, that is a1, and at this point it reaches a maximum velocity, that is Vm. Okay, Vm. So from that point onwards it starts to decelerate with a constant deceleration, that is a2, and finally it comes to rest. Okay, so the time, the first portion of the journey, that is for T1 is the time taken by the train to reach the maximum velocity Vm, and T2 is the time taken by the train to from the maximum velocity to come to rest. Okay, so T2 is the time. So we have given, that is suppose S1 is the distance traveled by the train. Okay, so S1 is the distance and S2 is the distance traveled by the train. Okay, so we have given, that is T1 plus, the question is given T1 plus T2 is equal to 4, S1 plus S2 is equal to, that is 4 minutes, that is 4 km. Okay, 4 km. Okay, so S1 plus S2 is equal to, from this S1 plus F2 is equal to, so the total displacement or total distance traveled by the train, that is equal to half into T1 plus T2. Okay, T1 plus T2 into, that is height Vm. Okay, so S1 plus S2 given, that is 4, is equal to 1 by 2 into T1 plus T2, that is also 4 into Vm. So 2 get cancelled. Okay, so therefore Vm is equal to 2 km per minute. Okay, 2 km per minute. So that is the maximum velocity. Okay, so from the graph, suppose theta is the angle here. Okay, theta is the angle here. So tan theta is equal to perpendicular by base, that is Vm by T1. Okay, so tan theta is nothing but, that is acceleration, that is slope of the curve, that is nothing but acceleration. Okay, velocity time graph. So slope of the velocity time graph gives the acceleration. So a1 is equal to Vm. So we have find, that is 2 by T1. So from this T1 is equal to 2 by a1. Okay. So similarly we can write, that is a2 is equal to 2 by T2. Okay, T by T2. So T2 is equal to 2 by a2. Okay, so substitute the values on this equation. So T1 plus T2. So T1 plus T2 is equal to 4. So what is T1? That is 2 by a1 plus what is T2? That is 2 by a2, that's equal to 4. Take 2 commonly outside. So 2 into 1 by a1 plus 1 by a2 is equal to 4. Therefore, 1 by a1 plus 1 by a2 is equal to 2. Okay, 2. So that we have to prove, that is 1 by a1 plus 1 by a2 is equal to 2. Clear? So the next problem, that is 16th question. So consider a velocity displacement graph. Velocity displacement graph. Velocity displacement graph. Velocity meter per second, displacement meter. Okay. So this correspond to 6. 2. So 18. 10. Okay, 10. So find acceleration. Find acceleration when displacement x equal to 3 meter. X equal to 3. So the given graph is velocity, not velocity time graph, velocity displacement graph. Okay, velocity displacement graph. So we have to find the acceleration when displacement is equal to 3 meter. So when velocity in terms of, that is velocity is a function in terms of that is displacement. So we have studied on formula to find the acceleration. So acceleration is equal to v into dv by dx. Okay, acceleration is equal to v into dv by dx. So where dv by dx, that is slope of the curve. Okay, slope of the curve. Okay, here, so slope of the curve means that is dv by dx equal to, that is y2 minus y1 divided by x2 minus x1. Okay, so x1 y1, x2 y2. So here so this point I am taking, that is A and this is B. Okay, B. So x1 y1, so here that is x, that is 2, y1 that is 18. So this point x1 that is 6, y1 that is 10. Okay, so substitute the values. So y2 minus, that is 6 minus y1 that is 18 divided by x2, x2 that is 6 minus x1 that is 2. So that's equal to that is y2 that is 10. Okay, y2 10. So 10 minus 80. So that's equal to minus 8 divided by 4. So that's equal to minus 2. dv by dx equal to minus 2. Okay, minus 2. So what is v? That is v is the velocity corresponding to the displacement at that is 3 meter. Okay, 3 meter. So 3. Okay, 3. So that is V. Okay. So from this these two triangles, that is AB ABC and this triangle DE, okay. So this triangle ABC and ADs are similar triangles, okay, similar triangles. So from this we can write that is similar triangle means we can write that is AC by CB is equal to AD by D. Okay. So what is AC? AC means 10 to 18 minus 10, that is 8. Okay, 8 by CB. So that is 2 to 6, that is 4 is equal to what is AD? AD means that is 18 minus V divided by DE, that is 2 to 3, that is 1. Okay, so 2. So 18 minus V is equal to 2. Okay, 2. So V is equal to, that is 16. V is equal to 16. Okay. So what is acceleration? Acceleration is equal to V into dV by dx. So what is V? That is 16. 16 into what is dV by dx? That is minus 2. So that's equal to minus 32 meter per second square. So that is the answer. Okay. So here, so the velocity displacement graph. So we are using the formula A is equal to V into dV by dx. dV by dx is nothing but the slope of the curve. So we find the slope of the curve using dV by dx equal to y2 minus y1 by x2 minus x1. So the line is like that. So the slope is greater than 90 degrees. So that is negative slope. So dV by dx equal to minus 2. So V is nothing but the velocity corresponding to the displacement, that is 3 meters. So from this graph we are finding that is 3 is equal to corresponding the velocity at the displacement 3 is displacement x equal to 3 meter. Okay, so if we find that is V is equal to 6 meter by using the properties of similar triangles, we find the velocity, that is V is equal to 16 meter. So substitute the values, we get the answer, that is acceleration is equal to minus 32 meter per second square. Clear? 17th problem. Consider an acceleration time graph. Acceleration time graph. Consider the acceleration time graph. Find the equivalent velocity time graph. Find the velocity time graph. Option A, option B, option C, option D. So this is the acceleration time graph. So we have to find the equivalent velocity time graph. So here the acceleration is constant. Okay, acceleration is constant. So we know that the slope of the velocity time graph is acceleration. So if you want to get the constant, that is constant acceleration, means the slope must be constant. So here slope is constant. Okay, slope is constant. So for each and every point, if you find the slope, that is slope is constant. So here the first thing is, that is acceleration positive, acceleration constant. Okay, constant. So here, that is the angle, the slope of the angle is less than 90 degree. So that is acceleration is positive. Tan theta positive. Tan theta positive means slope positive. Slope positive means acceleration positive. Okay, acceleration positive. And also, if you find the angle at any points, each and every points, if you find the angle is constant. Okay, angle is constant. So acceleration, therefore acceleration is constant. So after that, acceleration becomes 0. So here, so from this point, that is acceleration, that is horizontal straight line, that is slope is equal to 0. Slope is equal to 0 means that is acceleration is equal to 0. Here slope is equal to 0. So after that, again, that is positive acceleration. Okay, positive acceleration, acceleration increases, that is from 0 acceleration increases, that is also acceleration is positive. Okay, positive. So here the line is like this. Okay, so acceleration increases, acceleration positive. Okay, acceleration positive, like this. Okay, so this is the equivalent velocity time graph for this acceleration time graph. So option B is the answer. So no other graph matches with this acceleration time graph. Okay, time graph. So here acceleration positive, acceleration 0, then acceleration becomes negative here. Okay, negative here. Here acceleration from the starting itself, acceleration is negative. Here also from the starting itself, acceleration is negative. So in our case, that is the acceleration is always positive. Always positive. So this graph don't match with this graph. So first acceleration positive, acceleration constant, then acceleration becomes 0, then acceleration again, that is constant, acceleration positive. So this graph only matches with this acceleration time graph. Okay. So 18th question. A body starts from rest and moving with the constant acceleration. Okay, moving with constant acceleration. So the variation of speed with the displacement x is. So find the curve, find the graph, of speed versus distance. So a body starts from rest and moving with a constant acceleration. So find the graph of speed versus distance. Okay, speed versus distance. Option A, is velocity displacement. Option B, option C, a body starts from rest and moving with the constant acceleration. So the variation of speed with the displacement x is. So we have to find the current curve. So v square, I am using the equation v square minus u square is equal to 2as. Okay. So the body starts from rest. So v square minus initial velocity 0 is equal to 2as. So v square is equal to 2as. Okay, 2as. So the final velocity and displacement relation is like this: v square is equal to 2as. So it is just like the equation, that is y square is equal to, that is 4ax. That is the standard equation of a parabola. Okay, standard equation of a parabola. So we have, that is 4 types of parabola. Okay, that is y square is equal to 4ax. Okay, 4ax. 4ax. It is y square is equal to 4ax. Okay, so this is the parabola. Y square is equal to 4ax. So this is y axis and this is x axis. Then y square is equal to minus 4ax. Minus 4ax. Parabola. Y square is equal to minus 4x. Then x square is equal to 4ay. X square is equal to 4ay. And x square is equal to minus 4ay. These are the 4 types of parabola. Okay, y square is equal to 4ax. So x means y is equal to 4ax means it is x axis. Okay, x axis. Y square is equal to minus 4ax means it is in the opposite direction. The parabola is in the opposite direction. Okay. So x square is equal to 4ay. Okay, that is x square. Square term in x, that is 4a, means the parabola in y axis. Okay, y axis. X square is equal to minus 4ay means opposite parabola. So you have to remember these 4 standard 4 parabolas and the equations, the corresponding equations. Okay, then you have to know about the symmetry of parabola also symmetry of parabola. Symmetry of parabola. Symmetry of parabola. So y square is equal to 4ax. Y square is equal to 4ax. Okay. So x equal to y square by 4a. Replace minus y with y. Okay, minus y with y. So x equal to minus y square divided by 4a. That's equal to y square by 4. So again we are getting the same value. So x equal to y square is equal to 4ax. So x equal to y square by 4a. So replace minus y with y. Replace minus y. Sorry, replace y with minus y. Okay, replace y with minus y. So x equal to minus y the whole square divided by 4a. That's equal to y square by 4a. So we are, even though we are replacing y with minus y, we are getting the same value. So x equal to y square by 4a. So this is this parabola, that is y square is equal to 4ax. This parabola is called, this parabola is symmetric about x-axis. Symmetric about x-axis. Symmetric about x-axis. This parabola is called symmetric about x-axis. Okay. Similarly, x square is equal to 4ay. Okay, x square is equal to 4ay. So from this, y is equal to x square by 4a. So replace x with minus x. So y is equal to minus x square divided by 4a. So y is equal to x square by 4a. So this parabola x square is equal to 4ay is called. Even though we are replacing x with minus x, we are getting the same equation, y is equal to x square by 4a. So this parabola x square is equal to 4ay is called symmetric about y-axis. Symmetric about y-axis. So these are the things you have to remember always. Okay, keep in mind. So the four types of parabola, and symmetric about x-axis and symmetric about y-axis. Okay. So come to our problem, that is the fourth graph is like this. So velocity time graph. Okay, velocity time graph like this. So an object, we are using the constant, the body is moving, the body starts from rest and moving with a constant acceleration. So we are using the kinematic equation v square minus u square is equal to 2as. So v square minus 0 is equal to 2as. So v square is equal to 2as. So it corresponds to the equation, that is y square is equal to 4ax. So definitely this equation resembles the equation of a parabola. Okay, parabola. Then so v square is equal to 2as. So replace v with minus v. So minus v square is equal to 2as. So again we are getting, that is v square is equal to 2as. So from this what we can conclude? So the equation, that is the graph, is symmetric about the displacement axis. So from this graph, which that is this is not, okay, this is not a parabola. So this is not a parabola. This is a parabola, and this is a parabola, and this is also a parabola. Okay, parabola. So which equation? That is v square is equal to 2as. That is, that equation resembles the equation of a parabola. That is, the shape of the curve must be a parabola. So parabola. So here in our answer, two parabolas are there. So to confirm that which parabola, so we are using, that is, to find the symmetry of the parabola. So for that I am putting, that is replace v with minus v. So minus v square is equal to 2as. So v square is equal to 2as. So from this what we can conclude, that is the parabola is symmetric about the displacement axis. Symmetric about displacement axis is, this is the answer. Okay, this is the answer. Clear? So problem number 19. Okay, so consider a tower of height 900 meter. Okay, a boy is of height 900 meter. Meter. A boy is standing on the top of the tower. A boy is standing he is projected vertically upwards. He projected a ball vertically upwards with a velocity u is equal to, that is 20 meter per second. Meter per second. So, what is the trajectory of the ball? So, the ball goes upwards, that is, it reaches a maximum height. At that point, the velocity of the ball becomes 0. It comes to the original position and it reaches the ground. Okay, reaches the ground. So, this is the trajectory of the ball. Okay, trajectory of the ball. So, at that point, the velocity at the top, that is velocity is equal to 0. So, our question is draw the displacement time graph for the motion of the ball. Motion of the ball. Take the point of projection as the origin. Okay. So this is a tower of height 100 meter. A boy is standing on the top of the tower. He projected a ball vertically upwards starting with an initial velocity of 20 meter per second. So this is the trajectory of the ball. That is, the ball, as the ball goes upwards, the velocity velocity decreases and it reaches a maximum point where the velocity becomes 0, and after that the ball comes down to the original position and finally to the ground. So we have to find the draw the displacement time graph for the motion of the ball. Okay. The ball is projected, that is time t is equal to 0. Okay, t is equal to 0. When the ball reaches the maximum height, so maximum height, what is the time? So I am using the equation v is equal to u plus at. So at that point the velocity becomes 0, is equal to initial velocity, that is 20, plus acceleration always minus, that is minus 10t. Okay, so minus 10t is equal to minus 20. So t is equal to 2 seconds. Okay, so when the time t is equal to 2 seconds, the ball reaches the maximum height. Okay, so we know that when the ball returns to the original position, mean position, what is the time? That is, time is equal to 4 seconds. Okay, that is the time for the upward motion and the downward motion is the same. So the time for the reaches the t is equal to 2 seconds, t is equal to 4 seconds, reaches the height. So what is the time taken by the ball to reach the ground? So from this I am considering the motion, the ball reaches the maximum height okay, maximum height and comes down to the ground. So we can find the time, that is t is equal to root of from this equation, that is from this point onwards I am considering the motion. The ball it's just like the free fall, okay, free fall. So 100 plus okay, so what is the maximum height reached by the ball? That is the distance maximum height reached by the ball, that is v square minus u square is equal to 2as. Okay, v square minus u square is equal to 2as. So at the topmost position the ball's velocity is 0 minus initial velocity, that is 20 square is equal to 2 into minus 10 into s. We have to find out. This minus minus cancel. So s is equal to 20 into 20 divided by 2 into 10. So cancel, 2 to cancel. So s is equal to 20 meter. S is equal to 20 meter. So from the mean position the ball reached the height, that is 20 meter. Okay, 20 meter. So how much time it will take from this point to this point? How much time the ball will take to reach the ground? So we can use the equation, that is this equation only, s is equal to ut plus half at square. Okay, half at square. So from this equation we can find, that is t is equal to root of 2h by a. Okay, that's equal to root of 2 into, that is 100 plus 20, that is 120 divided by a, that is 10. Okay, cancel 12 into 2, that is 24. That's equal to root of 6 into 4, that is 2 root 6 second. 2 root 6 second. So the time taken by the ball to reach the ground is t is equal to 2 root 6 second. Okay, second. So now we can draw the displacement time graph. Okay, displacement time graph. Displacement time graph. So time t is equal to 0. T is equal to 0. When the ball reaches the height, this height time t is equal to that is 2 seconds. When the ball returns to the mean position, time is equal to, that is 4 seconds. When the ball reaches the ground, the time taken is 2 root 6 seconds. Okay, 2 root 6 seconds. Okay, 2 root 6 seconds. Then the displacement traveled by the body when time t is equal to 0, distance 0. When time t is equal to 2 seconds, that is 20 meter. Am I right? That is 20 meter. Okay, 20 meters. So this is displacement time graph. Okay, displacement time graph. 20 meter. So when the time the ball reaches to the mean position, that is 4 seconds, that is the ball comes to the original position, that is displacement is 0. Okay, displacement is 0. When the ball, that is at the time 2 root 6 seconds, it reaches the height, that is minus 100 meter. Right? Minus 100 meter. That is minus 100 meter. Minus 100. Okay. So now this time, that is 4 seconds, it becomes 0. 2 root 6, that is it becomes okay. So we have to draw the graph, okay, connecting these points. So according to that is in such a way that we have to draw the graph in such a way that the graph gives the velocity, because from the distance displacement velocity graph we have to find the velocity, okay, velocity. So according to that only we have to draw the graph. So when the ball is projected, when the ball goes upwards, it is up to 2 seconds, that is the velocity decreases, okay, velocity decreases. So the curve is like this. Okay, it's like this. Then from this on, that is the velocity increases. Okay, velocity at this point the velocity becomes 0, and after that the velocity increases. Okay, that is from this point to this point, up to this point, that is the velocity increases. Also the velocity is negative. Here the velocity is positive. Okay, velocity is positive. That is, if you draw the tangent, that is it is less than 90 degree. So we will get, that is velocity positive. So here if you draw the tangent, that is velocity, it is velocity negative increasing, velocity negative increasing. Okay, so up to, from this point to up to this point, that is the single journey, that is velocity negative increasing. Okay, velocity negative increasing. Right. Okay, so this is the displacement time graph of the motion of the ball. Clear? Next is for the same case, draw the distance time graph. Distance time graph. Okay. So when we draw the displacement distance time graph, means the distance is always positive. So in the previous case we have drawn the displacement time graph. So displacement time graph, so the motion of the ball from this point to this point only, that is displacement is positive. Okay, when the ball comes down, the displacement is negative. Okay, displacement is negative. So here when you draw the distance time graph, distance is always positively. Okay, positively. So according to that we have to draw the graph. So how to draw the distance time graph? Distance time graph, when time t is equal to 0, distance equal to 0. When time t is equal to 2 seconds, the distance traveled by the ball is 20 meter. Okay, the distance traveled by the meter, that is s is equal to 20 meter. When time t is equal to 4 seconds, the distance traveled by the body, that is 20 plus 20, that is 40 meter. Okay, when time t is equal to 2 root 6 seconds, that is the distance traveled by the body is 40 plus 100, that is 140 meter. Okay, so according to that we have to draw the graph. Okay, so this is a distance time graph. When time t is equal to 0, the distance equal to 0. When time t is equal to 2 seconds, the distance traveled by the ball is, that is 20 meter. Okay, 20 meter. 20 meter. When time t is equal to 4 seconds, okay, 4 seconds, The distance traveled by the ball is 40 meter. This is 20. This is 40. Meter. When time t is equal to 2 root 6, okay, 2 root 6 seconds. Seconds. 4 seconds, 2 root 6 seconds. The distance traveled by the ball, that is 140 meter. Is 140 meter. Okay, so from up to time 2 seconds, that is the speed decreases. Okay, so when you consider the motion of the ball from this point to this point, that is the time 2 seconds, the speed decreases. So from this point to this point, the speed increases. Okay, speed increases. So the slope of the distance time graph gives the speed. So according to that, we have to draw the graph. So speed decreases, though the curve is like this. Okay, curve is like this. So from this point to this point, the speed increases. So how will be the curve? It will be the curve. So again speed increases. So the curve is like this. Like this. So this point to time 2 seconds, the speed decreases. Speed is always positive. Okay, speed is always positive. So the curve, that is, if you draw the tangent, that is speed decreases. Okay, speed decreases. So from this point to, that is 4 seconds to 2 root 6 seconds. From time 2 seconds to 4 seconds, then 4 seconds to 2 root 6 seconds, the speed increases. So the curve will go like this. Okay. So this is the distance time graph for the same case. Okay. So draw the velocity time graph for the motion of the ball. Motion of the ball. So at a time t is equal to 0, what is the velocity? Velocity is equal to 20 meter per second. T is equal to 2 seconds, velocity is equal to 0. T is equal to 4 seconds, velocity is equal to minus 20 meter per second. Okay. When the ball returns to the mean position, it comes with the velocity as that of the ball is projected. Okay. So here in the downward direction, so velocity is negative. So t is equal to 2 root 6 seconds. So 2 root 6 seconds. What is the velocity? V is equal to root of 2gh. So that's equal to root of 2 into 10 into what is h? That is 120. So that's equal to 20 root 6. Okay, 20 root 6. Okay, so connecting all these points, we can draw the graph, velocity time graph. Okay, velocity time graph. So time t is equal to 2 seconds, 4 seconds. Okay, t is equal to 4 seconds and t is equal to 2 root 6. T is equal to 2 root 6. So t is equal to 20. At a time t is equal to, that is 20 meter per second. That is velocity time graph. Okay, velocity time graph, that is 20 meter per second. T is equal to 2 seconds. That is 2 seconds. That is velocity is equal to 0. Velocity is equal to 0. Okay, t is equal to 4 seconds. That is minus 20. Minus 20. So t is equal to, that is 20 root 6. 2 root 6 means it is 20 root 6. 20 root 6. So connecting all these points, you have to draw the graph. Okay. So when time t is equal to 0, it is velocity 0. Okay, velocity 0. Slight bend is there in the graph. Okay. So this is the velocity time graph. Okay, velocity time graph. Velocity time graph. Velocity time graph. At a time t is equal to 0, the velocity 20. At a time t is equal to 2 seconds, the ball t is equal to 0 seconds means ball is projected. At a time t is equal to 2 seconds means the ball reaches the maximum height, the velocity becomes 0. Then t is equal to 4 seconds means the ball returns to the mean position, that is 20, minus 20. Okay, minus 20 root 6. Okay, then t is equal to 20, that is the time t is equal to 2 root 6 means the velocity is minus 20 root 6. So this is the graph of this. So throughout it is a straight line graph, because throughout the concept velocity, that is acceleration, is constant. Acceleration is constant. Okay, acceleration is constant. So we will get the straight line graph. So when we draw the velocity time graph, we have to consider about acceleration, because the slope of the velocity time graph gives the acceleration. So throughout the motion, acceleration is constant, always, that is minus, so always 9.8. So acceleration is constant. So the velocity time graph is always straight line. Okay, straight line. Clear? A rocket is projected vertically upwards. That is 20th problem. A rocket is projected vertically upwards. Okay, upwards. So the velocity time graph of the rocket is given. It is 20, 40, 60, 80, 120. Okay. Velocity time graph. Velocity time graph. So that is 1000 meter per second. Okay, so what is the maximum height attained by the rocket? What is the maximum height attained by the rocket? So the The area under the velocity time graph gives the distance traveled by the object. Distance traveled by the object. So from 120 onwards, that is the velocity goes in the negative direction. Okay, velocity goes in the negative direction. That is the time t is equal to 120 seconds only the rocket comes down. Okay, so at that up to 120 seconds the rocket goes in the upward direction. So the area under this velocity time graph, velocity time curve gives the maximum height attained by the rocket. Clear? So maximum height is equal to half into base, that is 120 into, that is maximum, that is 1000. Okay, 1000. So 60, so 60 that is 60 into 1000, 16,000, that is 60 kilometer. 60 kilometer is the answer. Okay.